Hello, today we'll be discussing Reynolds experiment. Reynolds number is defined as a dimensionless quantity that is used to determine the type of flow pattern as laminar or turbulent while flowing through a pipe. The formula for Reynolds number is VL rho over mu. V is the flow speed, L is the characteristic linear dimension, rho is the density of the fluid, and mu is the dynamic viscosity of the fluid. There are three types of fluid flows: laminar, transitional, and turbulent. Laminar flow is a type of fluid flow where the fluid moves in smooth parallel layers without disruption between them. The Reynolds number for laminar flow should be less than 2,300. Transitional flow is a fluid flow state that occurs between laminar and turbulent flow, exhibiting characteristics of both. The Reynolds number for transitional flow should be between 2,300 and 4,000. Turbulent flow is a type of flow in which the fluid undergoes irregular fluctuations or mixing. The Reynolds number for turbulent flow should be greater than 4,000. The materials used to complete this experiment were a large storage container, a small storage container, a 1.5 inch PVC ball valve, a 3D printed male threaded adapter, 3/8 inch clear tubing, silicone sealant, plumber's putty, a turkey injection kit needle, a 5-gallon bucket, food coloring, and paper clips. For this experiment, we will be doing 2 laminar flow trials, 1 transitional flow trial, and 2 turbulent trials. For each trial, we will time how long it takes for each flow to reach 1 liter or 1,000 cubic centimeters. First, we fill the large container with water and fill the smaller one with dye and water. Open the ball valve slightly to achieve laminar flow and time each trial. Open the ball valve about halfway to achieve transitional flow and time each trial. Open the ball valve fully to achieve turbulent flow and time each trial. The temperature of the water was 74 degrees Fahrenheit, and now it's time for the calculations. For the first laminar flow trial, the flow rate was 4.96 times 10 to the negative 5 meters cubed per second, and the velocity was 0.0435 meters per second, and the Reynolds number was 1,771. For the second laminar flow trial, the flow rate was 5.66 times 10 to the negative 5 meters cubed per second, and the velocity was 0.0497 meters per second, and the Reynolds number was 2,024. For the transitional flow trial, the flow rate was 9.79 times 10 to the negative 5 meters cubed per second, and the velocity was 0.0859 meters per second, and the Reynolds number was 3,500. For the first turbulent flow trial, the flow rate was 2.48 times 10 to the negative 4 meters cubed per second, the velocity was 0.2174 meters per second, and the Reynolds number was 8,856. For the second turbulent flow trial, the flow rate was 2.52 times 10 to the negative 4 meters cubed per second, and the velocity was 0.2209 meters per second, and the Reynolds number was 9,000. In conclusion, we calculated all of the Reynolds numbers, and they all match the ranges given for each fluid flow.
Thank you for watching.